Hi everyone and welcome to CityCon. I hope you are enjoying the main stage presentations. My name is Serge Poueme. I'm a senior DevOps engineer within the site reliability engineering team at SAP. And today I'm here to talk to you a bit about how Spinnaker is shaping delivery excellence at SAP with my colleague Mohamed.
Also a senior DevOps engineer, and I work as a part of the monitoring team, and I work in deploying and maintaining monitoring and performing management systems.
So before we dive into the details on how we use Spinnaker at SAP, we just want to briefly talk about our journey towards CI/CD, which essentially started a couple of years ago when our team was created and we were actually tasked to build a standard CI/CD pipeline blueprint for all the products that would be deployed by the site reliability engineering team. So we went through a couple of solution assessments, did several proof of concepts, and finally selected Spinnaker as a continuous delivery platform. So 2 years after, why did we choose Spinnaker? So the main reason was pipeline as code. Spinnaker offers that capability. We are able to create pipeline templates, reuse them across projects, and also share them across teams. And this is actually providing a lot of benefits to teams because we can also bake in best practices in those templates. Spinnaker is secure. It offers authentication and authorization, and teams can adjust it to meet the security needs. And Spinnaker is also extensible, so it's very easy to create new custom stages, write plugins in order to achieve new types of capabilities on Spinnaker. And of course, integration was one of the main factors also we were looking into. Our CI/CD environments already have several other platforms in place. We're talking here, for example, about Jenkins or Artifactory, and we want to make sure that our continuous delivery platform is also able to integrate very well with the existing solutions. And last but not least, Spinnaker is easy to operate and it is cloud native. So easy to operate because it has a UI that is very simple to consume by most of the teams. The UI is not confusing. And then it also helps when a team is not knowledgeable about Kubernetes. It actually helps moving faster and absorbing that knowledge very easily. And cloud native, which was also very important to us since Spinnaker is running on Kubernetes, and we can also implement all the Kubernetes best practices to our Spinnaker deployment. So we went through several iterations during the past 2 years. So starting by just operating a single CI/CD pipeline for a specific project, we got some positive feedback from the architects and the developers. And we also started with very little documentation, only 2 site reliability engineers operating the pipeline. And today we fully transitioned to a service team with the service team that is actually implementing or operating the solution and also implementing a lot of best practices, a lot of automation, looking at adoption challenges. Also, we'll talk about that a bit later. And we have a couple of great success stories to tell. So we currently serve 20 active customers. So these are internal customers. Most of them are development teams. And this is approximately 160 developers, 206 pipelines that are deploying to multiple cloud environments. So we're talking here about SAP Cloud Platform, AWS, Microsoft Azure, or Google Cloud Platform. And now I'll let Mohamed tell you a bit more about their success story and how Spinnaker is performing in their project.
Thank you, Serge. And here I'll talk to you about how our struggle with a shared pipeline before we were using Spinnaker. First thing was we had issues when we had a shared infrastructure, and that caused us problem in regards of when we're trying to make an update or to one of our components, when we try to test some of our application in an be very extra careful that we don't break anybody else's applications. And we're also dependent on other teams for successful builds. By that, I mean, whenever one team is trying to deploy their application into production, their application has to go to be successful for our application to go to production as well. So if one team, their application fails for some reason, we are stuck in our deployment to production. And that causes us to have a lot of time wasted by seeking external help or other teams to fix the issue or fix the issues in their application. So there was a wait time, and it was a bit exhausting to fix these issues that we don't usually have control of. And so by that, we were very not, and we needed to change. This is when we start using Spinnaker, and it helped us a lot in our automation for the infrastructure deployment. The first part we have a service that we use called Gartner. It's an open source SAP tool. What it does is actually an orchestration tool to deploy Kubernetes cluster across multiple cloud and providers. And we were able, like Serge team is able to configure that with the Spinnaker. So we were able to deploy our Kubernetes cluster using Spinnaker by triggering Gartner to deploy in these and whatever we want, GCP or SAP cluster in-house or AWS. And the second thing was the deployment of infrastructure components. As we have multiple environment, dev and stage and production, but we have some different configuration between all of them. So we were able to do that easily with our pipeline whenever we're deploying STO or Cert Manager or Dynatrace, for instance. And also very important step for us was securing our environment. As we are using multiple tools, we have to provide some tokens to communicate with other applications. So we're able to do that easily with the integration that Spinnaker has with Vault. And for disaster recovery as well, like we can spin up our environment from scratch with just a few clicks to deploy the infrastructure components to the application as well. And all that is done through the pipeline with Spinnaker. And here's an example of how we're deploying one agent operator. Just like I wanted to point out here in the example, like the YAML file is pretty simple. We just grab the reference file from Git, and then it gets deployed. And then we get another reference file for the one agent custom resources. This is where this is where we deploy in which namespace or a specific namespace or however we want. And here, for instance, I'm trying to show you how we're deploying through Gartner. And this is done first. We use and then we use the webhook get method, and we communicate with Gartner to be able to we also get the YAML file for the Gartner deployment. That's the specs for the cluster. Where do we want to deploy it? GCP or AWS? How big is the cluster? And what memory is you're going to use and all that. We can do that easily with Spinnaker here. And here, as you can see, this is an example of the deployment that we have, how we do get the config, then we, with success, then we post the vault, and we register our cluster with Salinas, which is the service for the Serge team that we use. And the second thing is how Spinnaker helped us application deployment here. The main thing that we were happy is that we had our own independent pipeline that was only used by our team. And also, each application was running and has its own pipeline. So if one application fails, it does not affect the other application deployment, which was a very nice thing to have. And it was easier for our teams to test their apps and do faster deployments and to recover fast if there's an issue for one before or anything like that, or there's a fix coming up. And we do a lot of testing before the code goes to production. Also, we do canary deployment for stage and prod environment. And this I will talk over in a bit. And so far, we've had 1,000 deployment, over 1,000 deployment to production in the past 6 months, which is a very large amount compared to what we had before when we were using a shared pipeline. And here, I'll talk about, here's trying to show our architecture for the deployment pipeline. And as I mentioned before, we have 3 clusters. One is dev, one is stage, and one is production. For the dev cluster, we created 2 namespaces. One is playground, and that one was requested by the developers because they needed a safe space where they can test and their applications in the cluster and see how it acts with different components there. And this is plus the development namespace that we have in the same cluster. So whenever developer pushes their code in their own environment, in their own branch, it goes to deploy in the playground. If he creates a pull request, it will go and deploy in the development namespace, and that will trigger a push deployment event to Dynatrace, our monitoring tool, and that is done after each successful deployment. And here, when things get interesting, whenever we're trying to push to production, we use the canary deployment style. And in a stage environment, we decided to have it to split the traffic 50% between the new version of the application and the older version of the application, and run multiple load tests and performance tests, and check the variation between the 2 applications and see compared to the previous one. If all our criteria is met, we push the test results and metrics to Dynatrace, and then if it's successful, 100% of the traffic now gets diverted to the new application, and the older pod, the older application gets deleted. And then whenever we go to production, we also use Canary as well, but this time we do it in an incremental way. So we start increasing the traffic to the newer application after it passes certain threshold for each step until it reaches 100%. If all is clear and it passes with no big variation or no problems, 100% traffic goes to the new app version, and then the pod of the older version gets deleted, and then we send a push deployment event to Dynatrace for monitoring.
So now that you've seen an example, a practical example of how Spinnaker is used on a project, let me tell you a bit more about how the SRE team is able to support these various projects. So what we did is first making sure that our Spinnaker landscape is central to our service. So our Spinnaker instance can actually target all the different Kubernetes clusters of all the various customers that we're working with. And it can also talk to our Vault service in order to retrieve secrets that are used during deployment. And of course, we have some monitoring in place. We are able to monitor the metrics from Spinnaker on Prometheus. We also have Dynatrace that gives us a lot of insights on how Spinnaker is doing, and we have a log management system that allows us to read the output logs from the microservices in real time and troubleshoot any issues. So we support actually dozens of projects using this architecture. And one of the main things that we did in order to allow the deployment of the Spinnaker landscape, or let's say to make the deployment of the Spinnaker landscape easier, is to create an automation that relies on Jenkins and essentially gets a Spinnaker configuration from a Git repository and is able to deploy that Spinnaker configuration using some specific steps or stages. So this gives the capability to the teams to perform some pull requests for changes to Spinnaker. Those pull requests can be reviewed and approved. When they're approved, there's a merge process that happens. And then Jenkins receives a webhook that triggers a pipeline and perform all the required actions. So the same pipeline can be used to restore Spinnaker in case of a disaster recovery, but it can also be used for rolling updates. And this has essentially allowed us to support our central Spinnaker landscape or service very easily. The landscape configuration is stored also in a Git repository as a YAML file. And this allows us to define as many landscapes as we want. So here, for example, this is a sample production landscape where we can identify the name of the production cluster that is going to run Spinnaker, certain aspects like the service accounts that are used, some post-deployment patches, for example, patching the Spinnaker deck UI service to make sure that it is exposed to the end users. And we've been improving this landscape configuration over time to make sure that it supports all the aspects of how we want to define and control the Spinnaker landscape. And in addition to this, we also tackle adoption challenges. So we faced several adoption challenges during all those projects. And there are 4 specific things that we focus on to make sure that we are able to tackle them. So the first one is our self-service API. So that API is a way for our customers to register their Kubernetes clusters, Docker registries, or Helm providers to the central Spinnaker configuration without knowing the details of Iliad. And that has been a very important part of the onboarding process to the Spinnaker landscape. The second one is our documentation. So we write and share in-depth documentation on our wiki page. It's very useful because it tells teams how to use the service and also what are the constraints and limitations. And we make sure that the documentation is always updated as we're going through changes and updates on the Spinnaker landscape. The third thing that we are looking into and we're working on is the starter kits. So starter kits are a way for us to make the development of pipelines easier. And we maintain both continuous integration starter kits and continuous delivery starter kits. In the case of Spinnaker, all the Spinnaker pipelines are actually baked into our continuous delivery starter kits. So teams are able to reuse those kits, those pipeline templates, and then quickly build Spinnaker deployment pipelines with very minimal effort. And the fourth thing we're doing to make sure that we can increase adoption of Spinnaker is coaching. So we provide coaching to all our customers. We have a dedicated Slack channel where they can ask questions. We set up office hours very often, and we have regular meetings with our customers, making sure that we get their feedback and that we do any improvement to Spinnaker in order to help them achieving the CI/CD goals. So now I just want to show briefly an example of one of our self-service API method. So this method is used to add a Kubernetes cluster to the Spinnaker config. As we said earlier, teams don't need to know the details of Iliad. They simply have to pass a JSON payload to the API, and then the API will do the required configuration in Iliad and will also trigger a redeployment of Spinnaker in order to update the landscapes. So this has helped improving our onboarding experience, but also helped us scaling up the service because our team members can actually focus on other tasks like security, while onboarding and configuration changes are handled by the API. And this is also a very critical part for the success of the service. And here I just want to briefly show you an example of a continuous delivery starter kit. So it's essentially a Git repository that teams can fork, and it comes with what we call spin templates and spin configs. So these are just Spinnaker configuration files for pipelines and Spinnaker templates for pipelines. And we have built also a wrapper on top of ROER and SpinCLI, which are the common command line interfaces used to interact with the Spinnaker API when it comes to manipulating the pipelines as code. And teams can make changes to the Git repository. They can make some commits, again, pull requests, reviews. These changes are approved, and then as soon as they're approved, there is a trigger that starts the Jenkins pipeline, and the Jenkins pipeline we call ROER or SpinCLI to create the Spinnaker application for the team, publish the templates that the team is using, and plan and create all the pipelines. So this has allowed the teams to reduce their learning curve and also the time to create, actually the time required, sorry, to create Spinnaker pipelines in production. And this ends our presentation. So thank you for listening to us. I hope you've enjoyed it. And we are now opening the floor for Q&A. Thanks. So I hope you've enjoyed the session. We are opening the floor for Q&A. So feel free to ask any questions you may have. So I'm wondering, Mohamed, how are we doing on timing? Do we still have like a few minutes left?
Yeah, I think so.
Yeah, okay.
Thank you, guys. Please, if you have any questions, you can just shoot at us. We're happy to answer them.
Okay, so Faye is asking, how much change do the teams need to make for the starter kits for their app? Very little changes. So the name of the name of the pipeline that has to be rendered is the first change, and then the name of the application that is where the pipeline is being deployed. And in addition, we're asking the teams also to specify the name of their Helm repository and also the name of their Kubernetes cluster. So these are the typical parameters that are used. So Sergio is asking about an easy way to install Spinnaker. So yeah, so we used Iliad at the beginning. It wasn't actually easy, but we did. We built that Jenkins wrapper on top of it. But today I would suggest you try to leverage operator. It's actually really interesting, and it's easy in that process. But at the same time, if you can, there is a new CLI called Klit that will be released by the Spinnaker team. Actually, it's already been released by the Spinnaker team, and it's actually much better than Iliad. So you should also consider that. And I will put all those links in the chat. Okay, so do we have any compliance concerns about any compliance concerns and how we factor them in the pipeline? So Mohamed, I'll let you answer that one.
I mean, the compliance, it depends between the teams. So for instance, as we did in we used STO in our deploying for the networking. So because we wanted something more secure. But so far, our compliances, we didn't have any issues for that. I hope that answered the questions.
So there was also a question about the starter kit. So I just pasted an answer to the chat for Jasmine. Unfortunately, not yet, but we're looking into it. It's something that eventually we will do. So Pavel is asking if we played around with Argo CD or Jenkins X yet. Yes, actually, there was an evaluation paper that we worked on for Argo CD. And before selecting Spinnaker, we used Jenkins X. There were teams asking for Jenkins X. It's actually picking up. There are some internal projects where Jenkins X is actually used. And Argo CD was also used for several projects at the same time that we were building Spinnaker. So there is no limitation usually in the environment, actually, at least in our landscape regarding those two tools. But teams are just trying as much as possible to get a solution that allows them to start up very fast. So there is not too much traction actually from now on those two, because there is a lot of focus being put on Spinnaker and Jenkins, and also a lot of libraries being built around those two tools.
Okay, so I see another question about the Canary. And yes, there was a kit provided by Serge team for the Canary, and we did have to do some configuration regarding STO, but these configuration were done in the deployments for the Kubernetes. And we had to create some configuration in the Canary pipeline, Canary configuration in Spinnaker itself. But yeah, there was some configuration in the starter kit provided by Serge team.
So Tony Garcia is asking if we are handling secrets. Yes, and I can also let Mohamed talk about that.
Yes, so we have integration, Spinnaker have integration with Vault, and this is how we handle all the integration, all the secrets with that. So just makes a call in the pipeline and deployment file, and we grab that secret from there, and it's deployed with the Kubernetes.
Yeah, so we also built a custom Spinnaker stage to be able to handle Vault, and we started working on a Vault plugin that in the early days of the Spinnaker plugin. So we started building it. It's not final yet, but we're looking into completing it probably this year, and probably releasing it also as an open source plugin. So how do those secrets get into Vault initially? Okay, so this is a different part of our current central service, where when teams are onboarding the platform called Solinas, which is the continuous delivery platform, they actually have also to run an API query using the same API that we use for Spinnaker to create the Vault space. And then that query actually also grants access to the individual team members that are part of the organization that is requesting it. And then teams can feed the secrets into Vault from Jenkins during the CI process. That's a possibility. What we've seen more and more is actually teams building some scripts to sometimes when secrets are dynamically generated to generate those secrets and call the Vault API to inject them, and then Spinnaker can retrieve them in the deployment stage. One thing to know is that our Vault is internal, so it is not exposed to the internet, and there is a dedicated link between the Spinnaker landscape and Vault. I hope that answers the question. So if there is no more questions, we thank you for listening, and also thank you for all the questions. And so, Mohamed, I guess it's a wrap.
It's done. Yeah. Thank you guys very much. And please, you guys have our LinkedIn. If you guys have any questions or anything, just contact us.
Thank you.
Thank you. Bye, guys.
Bye.